Welcome back. I hope that you are enjoying this journey of circles with me. Now, in this part, we are going to study about how or what a point does with a circle, what is its position and what are its different cases. Similarly, what we are going to study is that what a line does with respect to a circle. A very important case that we are going to discuss here is the tangents. So let's begin.
So let's start with another concept, that is position of a point with respect to a circle. Now what do we mean by this? Suppose that we have a point that is an arbitrary point. It can be at any place, and we have a circle. The equation of circle is given by x square plus y square plus 2gx plus 2fy plus c is equals to 0. And suppose that we have a point P. Now this point P can be anywhere. This point P can be here, which is outside the circle. This point P can wander here, that means it can be inside the circle, or this point P can wander on this circumference as well, that means it is on the circle. So we are interested in knowing that where is the point. If we know the coordinates and if we know the equation of circle, then we can draw the graph and we can locate the point on the graph, and then we can conclude that whether the point is inside, outside or on the circle. But again, this is a graphical representation. If we move to a much simpler method, that is how to find the position of a point mathematically, then we have a very easy approach to do this. Now if the point P, let's say that it lies outside, on or inside the circle. So if the point P is outside the circle, then this OP, that is the length or the distance between this point O and this point P, will be greater than equals to R. Now what is this OP? If I want to write OP is nothing as but x1 minus plus g square plus y1 plus f square root. If the distance between the center and this point P greater than radius, that means I can say that the point lies outside the circle. Okay, so this is what we are trying to say, that if OP is greater than R, then the point will be outside the circle. Now that means what is happening here, if you expand this equation, then it will come up to this form. That means in this general equation we are trying to put this point x1 y1, and then we are trying to analyze what is the sign of this expression. So similar thing, I can say that let's say this be x1 plus g and y1 plus f square greater than equals to r square. Greater than r square, that means it is outside. Equal to r square, that means it's on the side. Okay, and if it's less than r square, then it's inside. So you can clearly see that I have just squared this equation, and this is here of this form. Let's call this equation of ours as S1. That means now S1 is a general notation. If I'm talking about S1, that means I am putting the point x1 y1 in the equation of circle. If I'm talking about S2, that means I am putting the point x2 y2 in the equation of circle. So S1 is a general notation which we are going to use further in the chapter as well. So always remember that S1 is nothing but you have a point x1 y1 and you have put it up this point in the equation of circle. Now let's come to the conditions. What conditions govern this point P's situation? So the first condition is that if this S1 is greater than 0, that means this OP is greater than R, then the point lies outside. Similarly, if S1 is less than 0, that means the point lies inside, because the distance between OP is less than R, that means it has to have somewhere here. If S1 is equals to 0, then the point lies on the circle. And again, our general thing, that is S1, as I have already told you, that it is nothing but x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equals to 0. So these are the cases to find out a position of a point with respect to a circle. Now let's move to the equation of tangent. But first of all, what is a tangent? So the tangent at any point of a circle, tangent at any point of a circle. For example, suppose this is the point. So tangent at this point on a circle is defined as a straight line which meets the circle at that point. That means if I have taken this point, then this straight line is going to meet the circle at this point only. But it does not going to cut when I produce it further. Okay, so that means it's not a chord. It's just a line that is touching the circle. It is not intersecting the circles at 2 points. It is just touching, intersecting at 1 point. Now the point where the tangent meets the circle, it is called the point of contact, because that is the only point where tangent and circle are meeting each other. So that is the point of contact. Now again, this was the figurative explanation. Now how to find it out mathematically? Let's say that the equation of a circle is x square plus y square plus 2gx plus 2fy plus c equals to 0. And let's suppose that there is a point x1, y1 which is on the circle. Remember, I am telling that the point is on the circle. This is very important thing, point on the circle. So the equation of tangent is given by x(x1) plus y(y1) plus g of x plus x1 plus f of y plus y1 plus c is equals to 0. That means if the point is on the circle, actually this equation is same to this equation. What has happened that, suppose because this point is on the circle, what has happened that x square has transformed to x(x1), y square has transformed to y(y1), 2gx has been transformed to g of x plus x1. Similarly, 2fy has been transformed to f of y plus y1, and c remains as it is. This equation we call it as t is equals to 0. This is again a general notation. T is equals to 0. We are going to use it many places, but remember that if a point is on the circle and you want to find out the equation of the circle, then the general notation is t is equals to 0. You just have to remember this. And how to get t? You can get t by using these transformations. These are the transformations that you are going to use in order to get t. So t is equals to 0 is equation of tangent. That's it. And the point lies on the circle. Remember, this is important, that point lies on the circle. This is a point of confusion. Many students do this confusion. They don't know that where the point lies and they just do the calculation. An easy way to check whether this point is lying on the circle or not is to put this point in this equation and see whether LHS is equal to RHS or not. Or we have just now studied position of a point with respect to a circle. So you can use that concept to understand that where the point lies. Now, if the point is on the circle, that means that is this one point. So only one tangent can be drawn. Again, two lines who cannot, if there is this point, then only one line can pass through here. I'll tell you how. So we'll come to the condition of tangency. Now suppose that you have a line y is equals to mx plus c, and I am saying that let's say this line be tangent to this circle. Now if I'm saying that this line be tangent to circle, then that means that the line and the circle meets at one point. So I can say that if I write x square and if I put the value of y here, mx plus c square is equals to a square, then this is what I'm doing here. I am trying to satisfy the line with the circle. That means this equation will give me at how many points the circle and line are meeting, or what are the values of x that will satisfy both the line and the circle simultaneously. Now, because we are trying to find the condition of tangency, that means we want only one value out of this, but it's a quadratic. It will give you two values and we want one value. So we want one value from a quadratic, that means we want discriminant of this equation to be equal to 0. Again, repeated root case from the quadratic equations. So for this equation we want d equal to 0 so that there is only one root. That means the circle and line touches at only one point. When you put d equal to 0, you will get c square is equals to a square of m square plus 1. This is a very important result. This is called the condition of tangency. If your line y is equals to mx plus c is a tangent to the circle, then the condition lies on c. C has to be equal to a square of 1 plus m square. And the point of contact, that means the point at which the tangent and circle are in contact, it is directly given by minus a square m by c and a square by c. So this equation is giving us lots and lots of information. We just have to play smart, satisfy the value with the circle, and you can see that it's a quadratic, so it will give you two values of x, but you want only one because the tangent and circle touches at only one point. So what you're going to do, you're going to put d equal to 0, that is the discriminant of that equation, combined equation. That means my equation becomes y is equals to mx. Now this is c square, we need c, so we have to take root. If we take root, then a plus minus sign will come, so y is equals to mx plus minus a of under root 1 plus m square. What does this mean? Why are there is this plus minus? What is the significance of this plus minus? The significance is that, now look carefully, you have decided the value of m and we are trying to find out the value of c. That means m is fixed and we are trying to find out c. Remember, m is fixed. Now this plus minus sign telling me that with a specific value of m there are going to be two tangents. But how is that possible? Look, suppose if this is the line with m, this is the line with m as well, because both the lines are parallel. Both have slope m. It's just that one equation has plus c or plus a under root of 1 plus m square. Other equation has minus a root of 1 plus m square. But you can see that the slope of both the lines is m. And that means they are parallel, same slope, parallel. So that is why by using any specific value of slope, two tangents can be drawn to any circle. You can see that there is no condition being imposed on m. So you can take any value of m accordingly. Also this case will always be positive and will always be valid. So you can take any value of m. For each and every value of m there will be two tangents to the circle. I am saying it again. For each and every value of m that you choose, there will be two tangents to any circle. Okay, and this will always be a tangent. Again, as I have said, that this will always be a tangent irrespective of value of m. So let's move. Now let's check our knowledge for one more question. A straight line which touches the circle x square plus y square is equals to r square. Then we need to prove that this point lies on a circle, on any circle. Okay, so let's see how we can prove it. Because there is a straight line which is touching the circle, now we know the condition that if it's a tangent, that means perpendicular from center will be equal to radius, and in this case center of the circle is 0, 0. So our equation L is actually x upon a plus y upon b minus 1 is equals to 0. If I drop a perpendicular from origin, then this will become 0 plus 0 minus 1 divided by root of 1 upon a square plus 1 upon b square mod is equals to r. If I square and do the rearrangement, I will get 1 upon a square plus 1 upon b square is equals to 1 upon r square. Now the point is 1 upon a, 1 upon b. That means if I write this equation like this, x square plus y square is equals to 1 upon r square, that means that if you put 1 upon a and 1 upon b here, you will get this equation, and that means that 1 upon a, 1 upon b lies on this circle. It's also a circle whose radius is 1 upon r. So hence we have proved that 1 upon a, 1 upon b lies on the circle. The question says that lies on a circle, so it can be any circle.
So this is it about a position of a point and line with respect to circle. I hope that you have carefully noted that how the different forms of equations of tangent are there and what are their equations. Now this is it for this part. I hope that you have understood, and for the next part we are going to study the interaction of two circles. Thank you.